The next topic we want to discuss is how we can use integrals to find the area between two curves. And in particular, we want to talk about how this differs from what we've already been doing with integration. So with the problems we've considered so far, we've calculated definite integrals, and that result could either be positive or negative. And that came down to whether the area we were calculating was above the x-axis or below the x-axis. When we evaluate the area between two curves, our result will always be positive. So let's take a look at how that's going to be the case. So in example 1, we want to set up a definite integral that represents the shaded area. So what we have is a shaded region below this curve f of x. So it's bounded above by the curve f of x, and in this case, even though it's not represented here, bounded below by the curve g of x. And then we're looking at this area from a lower bound of x equals -2 to an upper bound of x equals +2. So we could write an integral of the form integrating from -2 to 2, and then to represent finding the area between these two curves, we'll identify whichever function is taking on the greater function values. So in this case, f of x always has the larger function values. So we would integrate f of x minus the function that's taking on the smaller function values, which in this case is g of x, dx. So to find the area between our two curves, we look at the function that's taking on the larger function values, and then subtract away from that the function taking on the smaller function values. Now in this case, this function g of x is exactly the same thing as the line y equals 0. So exactly the same as the x-axis. So we could replace g of x with 0 and write this as the integral from -2 to 2 of f of x dx. So in this case, what we end up with is an integral that's identical to the types of problems we've considered before, because what a definite integral does, on its own, if we were just considering a single function, it finds the area between that curve and the x-axis. Since in this case that area is above the x-axis, there's no difference between this expression and finding the area between two curves, since that second curve in this case is just the x-axis. In the second example, though, we'll see how this idea of calculating the area between two curves changes things. So we have, again, some function, f of x. We want to find the area with a lower bound of x equals -2, an upper bound of x equals +2. So if we were to take the definite integral of this function from -2 to 2, we would end up with a negative result, because this area is below the x-axis. But again, what we're going to consider now is calculating the area between these two curves. Where here again we have this second function, g of x, which is equal to the x-axis or that line y equals 0. So we'll set up our definite integral in the same way. We'll look at the upper bound and lower bound, which in this case will be -2 to 2. We'll start with the function taking on the larger function value, which in this case is g of x, minus the function taking on the smaller function value, so minus f of x dx. Now, since we know that in this case g of x, that second function is just the x-axis, we could replace that with a 0. And our integral becomes the integral of -2 to 2 of negative f of x dx. So instead of integrating this area and coming up with what would have been a negative value, since that area is below the x-axis, this idea of finding the area between curves introduces this negative sign. So since we have that negative sign, that flips what would have been a negative area to being a positive area. So our result actually ends up being something positive. Versus in this case, if we just integrated from -2 to 2, without considering area between curves, just finding the definite integral of this function, we would have gotten some result less than 0. So using this idea of area between curves has two important things to keep in mind. We take the function taking on the greater values first, and then subtract the function taking on the smaller values. And the other idea is this is always going to force any area we calculate to be positive.